Hello and welcome to Azure Data Services at 50,000 feet. My name is Brian Kafferke and I'm a Microsoft Technical Solutions Professional. And I'm going to talk to you about Azure Data Services. But before I get into that, I wanted to point out that I am wearing my Microsoft hat, but I'm also drinking out of my R open source mug and wearing my, I don't know if you can see it, my Python shirt. So I'm covering all the bases, Microsoft, R, and Python, which might give you a clue that this is going to touch on machine learning as well. What I want to talk about first is a question that I get a lot, which is why are there so many different features and options? It's kind of bewildering. And not only that, but why are there so many new ones coming out all the time? Well, I want to step back, and it can be bewildering. If you feel overwhelmed by all the different options and features in Azure, you're not alone. I'm included. I think anybody really is. It's one of the reasons we kind of at Microsoft specialize in different areas, because there's just so much. But there's a reason, and it's to benefit the customer. And so I wanted to use the analogy of the golf bag, because I'm a terrible golfer, but if I were a good golfer, I probably want to have a bag with a lot of clubs. Now, I can only really hit with the 5 and 7 iron because I'm not good. But if I were a good golfer, like a professional, then each club would have a different purpose and would allow me to do different things. Some are for putting, some are like a pitching wedge to get me out of sand traps and things. Some are really like a driver for long range. And so the idea behind the clubs is, of course, each one has a different purpose, fits in a different way, and you use it differently. And so asking why there's so many options is kind of like asking, why do I have so many golf clubs? Which I did ask when I first started, but then you learn there's a reason, and when you know how to use them, it makes sense. Well, clearly in a case like Azure, where there's so many different enterprise with so many different needs across different industries, different requirements, Microsoft's trying to give you a wide range of options, whatever you want, open source, Windows based, or Linux based, or whatever you want. They need to support it across the board so that whatever you need can be met. And so that's why there's so many options. And so my goal today is to kind of demystify and clear up at least a piece of the Azure cloud, which is going to be focusing on the data services. With that in mind, I want to also step back and focus on data science, machine learning, and artificial intelligence, AI. So I'm not going to try to cover every piece. It will touch on, I think, pretty much all the data options you have, but, well, not all, but most of the more structured ones, the ones you tend to use in these areas. Because again, by focusing on that perspective, one, it's the area I focus on in my work, but it also gives us a way to slice at Azure and not be overwhelmed. And the other thing I want to do before I start is kind of make a distinction about really the data services offered on Azure, and I'm really going to be focusing on the right-hand side of this slide, which is platform as a service, versus infrastructure as a service, which generally what we talk about there is more like virtual machines or VMs. Now, when virtualization came along, everybody's excited, and it is great. You can spin up machines within machines, and they're virtual, so you can tear them down, spin them up. And then when the cloud came along, the idea is, hey, well, if we can do this on-prem, then I guess we could do this as a service in the cloud, and voila, it's great. But really, a VM, it does not kind of maximize the benefit of what you could be getting with the cloud, and that's where a platform as a service comes along, and is a variety of ways in which I think that's true. But the first most basic one is that if you spin up a virtual machine, whether it's on the cloud or on-prem, you still have to worry about what software you put on it. So if it's like SQL Server, then you got to worry about releases of SQL Server and testing them and making sure you don't break them and deploying them across different environments like development, QA, production. So you've got that to worry about. You also have to worry about the operating system, if it's Linux or SQL Server or any of those things. And by the way, SQL Server does run on Linux now, but those issues you still have to worry about. So personally, I don't like to worry about those headaches. My mentality, for what it's worth, is more of a developer. I just want to get in and do my job, and I like to just have things work. And I don't really like to have to go to people either in the organization and ask them for things. So the VM idea is good, but it still puts a lot of overhead, a lot of work on the user of the VM to do a lot of things. So platform as a service eliminates that. You use, whether it's a SQL Server as a service or a data lake or something like that, you just use the service and you pay for the service you're using, but you don't have to worry about maintaining operating systems. You don't even have to worry about licensing costs for the things you're using. You just worry about the application and the data. What are you doing? You have to worry about that. That's all that stuff. So on this slide, all that stuff in the dark blue parts of it are taken care of by Azure. Now, the other part of it I want to mention, though, is sometimes as services, you might think, well, why do I even want to do that? Or maybe you say that's fine. But there's another piece, which is there are abilities within the cloud that just cannot be replicated on-prem. At least unless you're some mega corporation, you wouldn't be able to do that. For instance, I have a thing on LinkedIn. I did an article which is called Hospital as a Service, and I kind of equate it to that. But the idea is there's certain things that will be very expensive. For instance, Cortana Intelligence has some reusable sort of general service models for artificial intelligence, like facial recognition or pattern recognition in images, or voice recognition, and machine learning built in, and all kinds of great things. These are this cost a lot of money for Microsoft to develop, and they can do that because they can share that among all their customers, defraying essentially the cost. They charge you as a service. It would not be practical for any enterprise, even if they could do it, to incur that kind of a cost just for their own use. It would just be too prohibitive cost-wise. So even a small company, even a small shop, can make use of these services, and it's so cheap basically that it scales across, so you can just use it and shut it down. So small companies now can do something that would have been only allowed or possible by really large companies before, like Google, say. So that's one of the other things. The other thing is, I want to mention, is that the sophistication of architecture, the ability to scale up and down in many flexible ways using containers like Docker, allows you to, even with machine learning, spin up, say, a predictive model and say, I'm going to spin it up in containers, and now like things like Kubernetes and Swarm and things, to allow you to set up something where it will actually create more containers when more demand is needed for you, say, your predictive model, and then bring it down later. Now, I haven't, to be honest, personally got into a lot of that yet, but that seems to be a direction I see this going in, so that you'll be able to scale up and down your machine learning and artificial intelligence solutions. And again, on-prem you could do that to a point, but how many servers do you want to have on-premise to allow this kind of flexible scaling? Because you have to actually pay for that hardware. All right, so there's my preaching and platform as a service. So this presentation is going to focus on platform as a service, because it really is that service space. As far as VMs, you can spin up whatever you want, where you want, and it's really more of a machine. So there isn't much for me to really add to that. And so we move on. Another thing I'm going to focus a little bit on at a more micro level here is the two most popular open source machine learning predictive modeling languages, R and Python. And I'm going to look at those because SQL Server and other Azure services actually integrate these languages in really nice ways in their products. So I want to point that out and highlight that a little bit, because it's not obvious. I don't think everyone realizes just how much that happens, and there seems to be a lot of direction at Microsoft to make even more of that happening. So I'm very excited about that. I'm a big R person, and more recently getting into Python, and I think they're both great languages. I think I can't really pick one or the other. If somebody said, which one do you think is better? I don't think one's better. I think they both have strengths and weaknesses. So it's great that they support them both. Well, I'll talk about machine learning integration within SQL Server, which is available for both languages as of SQL Server 2017, the newest release. So you can do that right in database, and I'll mention that a little bit more. So that's the other thing I want to talk about. So I'm going to do two layers of slides, just two pictures here. One with very high level, and the other I'll give a little more detail to explain what I'm doing. But to kind of look at this slide here, what I want to highlight really is, first, I'm trying to highlight R and Python support, and I'm using boxes. I know these aren't pretty pictures that you typically get. This is not something Microsoft created. I created this myself because I wanted to simplify the picture as much as possible so that it's not overwhelming. So I'm not using Power BI images and icons, and I'm not using all that branding. I'm just trying to hone in on what's going on. So at the upper right hand corner, I've got a little box, and it has R and Python as sort of a legend. And then in each box below, you can see if the R image is in that box, that means there's integration support for the R programming language. If Python's in it too, or is in it also, then that means it has Python integration support. And the first tier of boxes are really more client or development type tools, but I did want to touch on those because they relate to obviously the data side. And one is Power BI. So Power BI actually has good integration. You can put R scripts directly into Power BI solutions when you load your data, so you can do any kind of stuff you want on load. You can transform your data with R, and you can even do visualizations, custom visuals with R, which is great because if you like ggplot2 or something, you can put them right in there. It's great. Now, Azure Machine Learning Studio is a very slick, I think, visual drag and drop tool. It's in the portal, but it has a rich interface, very much like client-side tool, like on-prem kind of client tool, and that allows you to really, without any knowledge of programming, you can just drag and drop and say, oh, I need a database source. Let me drag that down. Oh, I need to split that data. Let me use the splitter task. And I have a little image just to give you an idea of that. But if you ever use something like SSIS or any kind of visual tool like that, even a little like well, not Power BI so much, but like SSIS where you're dragging components, that's the idea. And then you just set properties. So what's really great about that is even if you know nothing about programming, you can use Azure Machine Learning Studio and be creating powerful machine learning models in no time. It's really great. Now, if you want to do more of the programming side, you do want to get your hands dirty in code, you can use a new product, which is Machine Learning Workbench, Azure Machine Learning Workbench, which is really a client tool, but it integrates with cloud. So it's almost a hybrid tool, but it basically works with Azure and machine learning and allows you to write or work with Python code and develop your models and everything. So you get a greater granularity. There was a lot of talk actually at Ignite this year, and some people are like, why Workbench? What are we doing with that? And the point is, one, it is language based as opposed to just the drag and drop interface, and the other is it's meant to give you more granular control. So if you do feel comfortable with Python, then you can use Workbench. Now, it does not currently support R. I have not seen anything concrete that it will, but I have heard things, rumors, whatever. I think that would appear to be the direction down the road, but don't hold me to it, but it just seems to make sense. So you've got but currently it does support Python, so that's great. And now I'm going to work down the tier below this and talk about the data side of things. And I'm going to do it at a very quick level, then I'll get into a little more detail in a minute. So the idea of this green arrow at the bottom is to show scale. So on the left-hand side is like the lowest scale, and then scaling up what volume of data and things we can handle. And also mixed in here is structured and unstructured types of data. And unstructured, really, I should say, sort of multi-structured. It may have different types of formats, but it's not your traditional, say, SQL format. So that's also in there. That tends to be big data and volume support. But I'm kind of integrating these in because there are structured options which scale really well, and then there are unstructured like HDInsight. So kind of I'll walk my way through here. So if you want to do, you're going from, say, developing in R, say, on your own client machine, developing some models, you probably learn pretty quickly that if you try to pull in a lot of data, R is limited to your machine's memory. And when you try to go beyond that, it chokes and your machine tanks, and it's not a pretty picture. So the next option to scale up from that is to move on to using R Server. Now, a little background, Microsoft bought a company called Revolution Analytics. They have sold for a while this product, which is an R Server. And it really, if you think of what SQL Server is, you send a SQL statement to it, and an engine on a server that can make use of cores and parallel processing and everything spins up, and it does the work and then sends you the result. Same idea with an R Server. You send it R code, and it scales, and it can do all kinds of high performance stuff and give you the result. It can page memory in and out. It's not going to break if you run out of memory. It can handle parallel processing things. So it's much faster, and it can handle much larger sets of memory. So if you go from, say, client, just your individual machine, to a SQL Server on-prem or in the cloud, but a SQL Server, and that has machine learning server built in, that would allow you to scale to hundreds of millions of rows, which is pretty significant. That will handle a lot of cases. And that had been in R only in 2016, but now 2017 SQL Server supports Python as well that way. So it's really great. So now you have a great scalability option that can bring you to a lot of use cases, and I can talk more about that, but it also has great support for operationalizing. So I'll talk a little about that in a minute, but that's SQL Server. But say you realize, okay, that's great, but I need to move up a little more, and that's what these other options are. So then I'm going to kind of touch on these quick, and then we'll move to a little more detail that I can have more bullet points. So Azure Analysis Services is a way to scale essentially slice and dice. So this isn't really a SQL Server type solution, it's a BI solution. And Azure Analysis Services allows you to provide data to Excel or Power BI or something where you want to just dice and slice aggregated data, that kind of thing. Azure Data Lake Services is a full data lake analytics solution, but you pay as you go and you only pay for queries, and I'll talk a little about that in a minute. So it's a little bit less of a investment on your part when you use Azure Data Lake Services or Analytics. Azure Data Warehouse is actually a data warehouse appliance, so it's more on the level of Netezza or what had been Parallel Data Warehouse is now offered as a service within Azure. So it's multi heavy duty parallel processing, multiple cores, very high throughput. So you can do billions of rows, no problem, that it scales really high. Much better than just SQL Server. So don't, Azure Data Warehouse is a little bit misleading because you might think it's just a SQL Server star schema, but it's not. It's very high throughput. The next thing is SQL Server MI means managed instance, which is not currently available. I think it's still in private preview, and I'll try to highlight where those things are still in preview. So managed instance is private preview, but SQL DB has been around a long time. And I'm putting a little bullet here because our integration is planned for SQL DB. And the goal with SQL, we'll talk more about this, but the goal with SQL Server Managed Instance and SQL DB is to try to move you to the point where it's full SQL Server support, but it's not quite there yet, and we'll talk about that. Then we have Cosmos DB. I'll talk about that. HDInsight, and a new product that's really exciting, Databricks, which is kind of like HDInsight, but it's a separate company that actually owns Databricks, and it doesn't have to reside on Azure, but Azure has a lot of nice integration. So let's move on to a little more detail so I can cover this better. And I did mention Azure Machine Learning Studio, so I wanted to give you a flavor of that without you having to go track it down. So you can see on the left-hand side here, you've got this options to have saved data sets and data transformations and formats. So you can just drag these tasks from left to right. And you can see you have R language modules, so you can drop R language modules into there and all kinds of stuff like that. And Python language modules. So you've got integration support. If you do want to plug in pieces in Python or R, you can do that. But you can also just use the built-in pre-built components and build your models. So it's great. You can launch these models. You can schedule these models. If you notice the left-hand side, the toolbar, it has built-in Jupyter notebooks. And those are, they call them Azure notebooks, but it's just Jupyter notebooks running on Azure, which gives you collaboration support, all kinds of good stuff. So have a look at Azure ML Studio, but I did want to talk about that. Okay, this is just the slide we saw before, but more details because I want to highlight a few things. So again, we're looking at on-prem SQL Server, and I talked about that, I think, a fair degree. So the idea is the machine learning server that is built in to SQL Server allows you to share data between SQL Server and machine learning languages like Python or R without having to move the data in and out of the database. So really good. You can even write stored procedures in R or Python and compile them right into the database. And you have advantages like SQL Agent, which is a great job scheduler, so you can schedule your jobs to refresh predicted models and then maybe run use cases against the models and all those kinds of things. Really nice that way, and you can contain your models, the model data, everything you need, all within the SQL Server database. So it's kind of a great management container. And that upper right-hand corner, I have that little lock, and that what I wanted to accent there is just that really good security. So of course SQL Server is highly secure. You've got all kinds of options. So now when you're doing your predictive data and your modeling and everything, that benefits from all that security. But of course all the way across Azure there's Active Directory and all kinds of options to secure things. Okay, Azure Analysis Services. I want to talk a little bit more about that. The idea with Azure Analysis Services is when you do Power BI, it's querying and refreshing data from any number of sources, whether it's spreadsheets or flat files or databases, and it can be time consuming for it to one build that, but the other piece it can take it a while when you're trying to query the data because it may not scale too well. If you get a lot of data, you're kind of limited by how much it can fit because you're really relying on the client to load and show you the data. So the idea of analysis services is you can do one of two types of database models which will store the data and allow it to really scale well. So you can have millions and millions of rows, and it works really well, and when you slice and dice, it's instant. It's really fast. Now the more legacy method of doing that was called a multi-dimensional cube, and what that really meant was to some degree or other you could set how much you wanted it to do this, but what it does is really pre-aggregates. So if you think about all the different ways you could dice and slice your data by company codes and states and regions and cities and zip codes, what the cube did is it just pre-summarized and averaged and aggregated all that data and all those permutations and then saved them. And when you pull it out, it just sort of selects that right out of the dimension. It literally pulls it out and says, oh, you want that city summary by that state by this, and just pulls out the number. So that's fast. It persists the data on disk as opposed to in memory, and that's where the tabular model comes in. So the new tabular model is all in memory, highly compressed. They use Vertipack, highly compressed solution to take a large amount of data and compress it into a small space. So you can have very large data sets on the server's memory, and because it's in memory, when you slice and dice, it's instant, really quick. Now we go to SQL Server Managed Instance, also which emerges with SQLDB. So the idea behind managed instance is when you first probably saw a SQL database released as a service, SQLDB, it was just kind of a raw database. You could do selects and queries and etc., but it did not implement the full SQL Server stack. It did not only did it not implement the full SQL Server stack, which consists of 4 services, it did not implement the full database service. That's where the managed instance and other solutions are trying to solve that problem, because ideally it would be great if customers could just lift and shift and move over to Azure with their existing SQL loads and not have an impact, or at least minimal impact. So managed instance, what it can do, for instance, it gives you support, for instance, of things like link servers, the CLR, SQL Agent. And again, it's in testing, but SQL Agent is a big one for me. I love that. So you'll have that. And also what it is designed to do is let you scale up. So you don't just have to say, I've got one machine. I can say, I want 6 machines on this. I want to make a cluster of machines to support my SQL Server. So again, that's pretty scalable since you can make as many servers underneath as you want. Or you can just have one. So that's really the idea behind managed instance. And I'm going to have to do a whole presentation, I think, just on that. Go on YouTube and you can Google. There's some from Ignite that they go into a lot of detail. Now, one of the pieces I mentioned there's 4 services in SQL Server. So there's the database services, there's integration services, SSIS, there's analysis services, and then there's reporting services. Well, we can see from this slide, as a service, analysis services has been split out from SQL Server and made its own independent service, which makes sense because it really was never dependent on SQL Server in the first place. It was just a really nice service Microsoft is giving you sort of for free as part of SQL Server. But it makes sense to allow you to just use that. You may not want to use the SQL Server itself. You just want to use analysis services, and that's fine. So that's where that went. So if you want to lift and shift your analysis services stuff off to Azure, you can do that. The SQL Server database services are, after managed instance goes into general release or general acceptance, that will allow you to lift and shift probably about 90% of what you would see in your database engine instances. So even things like service broker and stuff is part of that. The piece that you might say, well, what about integration services, SSIS? What do I do with those? Because that's one of my strongest things I've done in the background. Did a lot of consulting in that. And so ETL is a challenge. It's an important part of especially data warehouse environments and things. That is also going to be allowing us to lift and shift. But again, thinking how you would want to lay it out in a sort of new world cloud, instead of making that part of SQL Server, it's been expanded into Azure's ETL process, which is really much bigger and wider in concept than SSIS, which is called Azure Data Factory. And Azure Data Factory, or ADF v2, right, second release, has a part of it now which will support SSIS packages right in Azure. So you can just lift them up and test them. I do a presentation on this. It's very cool. So you can now actually take your SSIS packages and put them right into Azure. Now this is also going through testing, so it's in private preview. So when I say you can do this, it will be possible to make that a production thing down the road. I don't know the exact dates at this point, but something to keep in mind is you can now lift and shift SSIS and plan on that down the road. You can do analysis services and you can do database services. Now the only thing not covered is if you use reporting services, and I don't know what the answer is going to be for that yet. So we'll have to get an answer to that. Okay, Azure Data Lake Analytics. Interesting thing, this Azure Data Lake Analytics. Pretty much it's like a data lake. But a couple of differences from HDInsight. Number one, you just say, I bring some data up, I could put it directly in Azure Data Lake Services and Azure Data Lake Analytics, and I don't pay to create clusters. I'm not going to have to pay to create machines and clusters and nodes underneath the data lake. Instead, think of it like a library where all the books are just there, right? And if I want one, I just pull it off the shelf, I read it, I put it back. And I'm going to pay for the time when I have it and I'm using it. So Azure Data Lake Analytics uses a language called uSQL. It's a little bit like Hive and Pig, or that kind of. It's kind of like Pig, I think it is, where you can query with a SQL-like language. But I think this implementation is richer, and it also is more like a combination of C# with SQL. And best of all, it also supports R and Python extensions. So if you do want to do R and Python, you can add these extensions in, and you'll be able to do that as also part of the language. But the key thing is, you're just using a bank of VMs that are available, and when you run your query, you put as a parameter how many units or how much you want this to scale. So you can say, I want a lot of units, I want a lot of nodes, and it will give you those. And when it's done, it's done. And you'll pay more money for that query, but also it's going to perform faster. So I couldn't tell you which works out better for price. But the nice thing is it's completely flexible, completely scalable, and you really don't have any kind of investment. You just pay as you go, literally on a query. All right, Azure Data Warehouse. So that's a data appliance. That's a warehouse appliance. So I mentioned like Teradata, Netezza, that kind of thing. If you think along those terms, structured data, support for SQL, not the full T-SQL support that you would have on SQL Server, but a pretty good implementation of those things. And the number one thing is because it's an appliance with powerful multi-parallel processing and multi-core support and everything, it will scale very well. So it's a great option when you just can't handle your database loads and say business intelligence, data warehousing, good option to push it into and scale up. HDInsight. HDInsight is really, think of the Apache data lake on the cloud and all kinds of options and things that entails, because the data lake on the cloud that Apache has lots of features. I don't know that all are in here, but a lot of them are the most common, and I'll try to show you some of that in a minute. So obviously unlimited scale, you can go into petabytes, you can do what you want. It also, if you're using like Internet of Things like that, you might be wanting to do streaming support, and it supports that using Spark as a backend. And you can also use R programming. It uses the R server and then connects that to Spark underneath the covers, so you can scale up with R, or you can use Python against it. So there's again the R Python integration you get. And then finally on the right is Cosmos DB. And Cosmos DB is a little different animal. It had been called Document DB previously, and then they renamed it to Cosmos DB. It's a multi-model, so graph, document database, etc., all these different types of things. Think MongoDB, that's part of what's in there. Another key thing about it is it's globally distributed, so you can partition your data where it will be located, parts of your data are located in different data centers, allowing it to be closer to the users, and therefore scaling up nicely that way. So it's globally scalable and distributed, scales out very well, and again, the multi-model support, so that when you want those graph database and things, that's kind of the answer. And it has Mongo compatibility, so if you've got Mongo code and everything, everything I say online, I've read, it says it will work here, and it should be compatible, so there it is. And again, the scale is going up. So I will point out, again, there's a sense of scale is going up as we go to the right, but what will scale better than what other? It really depends. A managed instance SQL Server, when that's generally available, that would scale up very high if you create enough clusters. HDInsight scales really high, so it all depends. Okay, and I'm going to talk also about another thing, which was the Databricks, but that's another thing. I'll discuss that in a little more detail. So HDInsight includes these features. So you get Apache Storm, which I think is basically a Hadoop, basically. And so that's, I think they renamed it, if I could be right. So Hadoop, HBase, Hive, Kafka, and of course Spark. So gives you a lot of options there. I mentioned Datalink Analytics. I just wanted to include a slide because until I see code, I don't really know what you're talking about. That's how I kind of work. So this is just a quick snapshot. This is a query that would go against a data analytics data lake. And you can see that it's got like one piece. It's taking data that's stored in the data lake as a TSV, tab separated file, and it pulls it in, and then it builds a table, and then it uses SQL to query against the table. In this case, it's then writing output. It could do any number of steps in between, so it could do a lot of stuff, but just to show you, and there's a link down below, you can sort of search for that and good stuff. Okay, Databricks on Azure, I'm really excited about, and you should be too, because it's interesting. It's very strongly similar to HDInsight, but there are a few differences. One of the biggest differences is Databricks is a self-contained world that allows you to completely manage your data lake, and especially Spark, I should say, really focusing on Spark, as a portal and a managed facility within the cloud. So it's kind of like a container within a container. So I like that. And I highlighted a few things. This came from, I think, Databricks' own site about what they're doing. But basically, you have, the first thing you should know is it integrates. So you can get Databricks on other environments, even like AWS, but you don't get the same level of integration you're getting when it's on Azure, because Microsoft works very closely with Databricks to get a very high level of integration. This is not available. It's still in private preview, but it's great because you can tie it into any number. All the things I'm talking about, you can just tie into and go through a Spark interface. And so obviously very scalable. You can also, you've got security is great because it integrates with Active Directory and role-based controls and all those things. And you're still going to get Azure's SLAs. So you're going to have all that high level of availability and guaranteed. So you get security, availability, all that good stuff. So really important. And on the right-hand side, the little legend shows that we can work with it with R, Python, or SQL. So those are three interfaces that you can use to get at this data in Spark. Excuse me. In addition to your standard, Spark type stuff. So this is a slide that just shows you a little bit what it looks like. So the basic interface to Databricks is a notebook. It's not a Jupyter notebook per se. It seems to be more of a tailored version of a Jupyter notebook, and supports Python, R, etc., and SQL. And you can see on the left-hand side, we've got things to create workspaces. We can create clusters. We can create jobs. So we can say, okay, this is great. Nice thing is I can go right in here, and if you look, you can say run all, and it just runs it like a program. You can bring files up or down, create clusters, and it's really quick. Just spins up a cluster, no problem. And then the little scheduling thing on toolbar on the right, you can actually say, I want to schedule this, say it's a predictive model. It creates a model. You can just schedule it to create the predictive model, and then you could have another job that uses a predictive model. So nice thing about this is it's self-contained, extremely fast. If you go on YouTube and things and just look up Databricks videos and things, and it really scales up well. So Databricks was founded by the people who created Spark, and I think their goal was to create something that made Spark that much easier to use, provide high service availability, provide kind of an all-in-one environment, really makes it turnkey. Again, if you talk, it's interesting because Databricks and Microsoft seem to have the same philosophy. Key is enablement. Make this easy to use. The goal isn't to make it, tricky and technical. The goal is to make it so that it's as easy to use as possible, so you can put it to use and not get headaches trying to do it or get stressed out. So really cool. Highly recommend taking a look at that. Okay, I do want to talk about something also I get asked, so I'm going to address it, which is people say, why Azure? Everyone says, I hear this a lot. I'm not really a big fan of the special sauce people say, but why Azure? What has Azure got that you don't find necessarily anywhere else? So I can't say I'm an expert on the other environments, though I have gone into other clouds and created some things. But the first thing I would say is you can almost see, just look at the companies involved. And Microsoft, I've been involved with Microsoft for decades. I date myself, I tell you how long, but a really long time. I remember Bill Gates, let's just say that. Anyway, and the thing, there are certain things about Microsoft that stand out that have been very consistent over time, and that's true in Azure, it's true in SQL Server. And the first thing that really comes out is, if you remember when Visual Basic came out, just as a sort of precursor to how Microsoft's, I think, philosophy is, Visual Basic took something that was actually really difficult. Creating Windows programs at that time was not trivial, and I remember, because I was trying to write in C, and I don't like having to work that hard. So then Visual Basic came out and it was like drag buttons down, double click, code, you're done. And that kind of philosophy goes through everything. Sometimes I think there are some programmers who think, oh, that's too easy. You need real coding. But I'm not of that philosophy. If you really like to do heavy duty grunging coding and you don't think things should be easy to do, then Microsoft tools wouldn't be the right thing. But if you want to be able to use the facilities and use the tools, use Spark, Hadoop, and anything with ease, then yeah, I think Azure's the right place. They do that. And I use that don't panic thing because I think of the Hitchhiker's Guide to the Galaxy, if you ever read it. It's a comedy sci-fi, and the idea in there is they say that the Hitchhiker's Guide to the Galaxy is the most popular book in the history of the universe, and most people think it's because it has the words don't panic in large friendly letters on the cover. So it's kind of funny. So I kind of see that that's a little like Microsoft, don't panic. They give you all the abilities, and they put all kinds of help and links. I mean, if you go into Azure, not only is the portal really graphically friendly, but there's links and everything to give you code, help everywhere. So that's my plug for it, and I just really like it that way. It's also, as I've mentioned and talked about, really good integration. All the pieces fit. You can tie and plug and play different pieces together. So when you talk about containers, you can say, wow, I could use containers with my machine learning models, and I can connect to Azure, I can do Databricks, I can do all these pieces. So it's really cool that you get this high level of integration. To me, integration it's been a big part of my career. I was an ATL developer and database warehouse developer for a long time, and that integration is very critical. Also, fluid scaling. So the idea is that I can start here, and maybe on my client, I can move to SQL Server. I can say, this isn't working enough. I can scale up to still being in SQL Server, no real changes, but I can be in a scaled up managed instance. Again, probably still in preview, but when that's there. So now I can scale up and I can create multiple machines. That's not good enough. I can go to data warehouse. So I'm still getting this consistency, and I'm not having to sort of throw away things and break everything as I move up. And I can, easily move between data lakes and HDInsight and all these pieces, so that scaling and the fact that I can just scale easily up or down dynamically. Other competitors can do that, but not with the level of integration and fluidity that I think that you can go between the things. So I like that a lot. This is a little bit vague, but I put enterprise solutions, and the main thinking here is just that Microsoft has worked with many different companies at many different scales in many different industries. So when they're putting out solutions, they're putting them out to be, industry strength, robust, and all these other features I'm talking about, and they're giving it the Microsoft backing for support and things, which I have as the last bullet. So I'll kind of leave that off. But it's not. They're not trying. They're not a company with solutions that are just fitting little niches, or they just fit small companies. They're designed to integrate and sort of fill in a wide area of IT for the enterprise. And finally, something that's really near and dear to my heart, I wrote a book on PowerShell a couple of years ago, and I love PowerShell. I think it's awesome. That's a Microsoft, really their answer to not really having a scripting language after the old DOS prompt. So PowerShell is it, and it is awesome. It is object oriented. It's just great. And not only PowerShell, but there are other options you can use to fully automate. So you can create VMs, you can create blob storage, you can create file systems, you create HDInsight, you can do any of these things. And there's always a module there in PowerShell that lets you create all these objects and automate it. Because once you create your environment, it's going to be pretty quickly obvious to you. You need to be able to turn things on and off quickly. You need to be able to spin up new things quickly and bring them down quickly, especially since you're paying as you go. It's a different model. It's not like you have a box just sitting that you've already paid for. This is something where you're paying, think of it more like dripping. It's, the Grand Canyon eventually wore through just dripping, right? So the idea here is you want to be able to spin things up and down and turn them off and disable them, and automation is key. So PowerShell is a great option, and I think obviously great support for that. But they also have using JSON files as a way to also automate pieces and spin things up, and that's been expanded. And I believe they're working on some Python modules that will also allow you to do the same things. There's even a CLI prompt you can go to within the Azure portal, and you can do work from there. So again, that automation key is a big one. It's something that you don't think of up front, but it's going to really be critical as you go forward, and I think it's a really strong point for Microsoft. All right, so that was my soapbox a little about that, but I think it's important to be able to say why do I think Azure is great. So wrapping up, we've covered a lot, and I've tried to really give you a perspective of scale from low to high, but also machine learning integration. R and Python are my two favorite languages really for this, because open source, free, and just amazing free modules out there available that you can just bring in and plug and play. So it's great, and I like the fact that it's integrated and supported throughout Azure in different places, and I tried to highlight that. And we saw a lot of other things. Keep your eyes open for Databricks. I think that's going to be a real game changer actually in Azure, and I'm excited about that. And as usual, please subscribe. I do all kinds of things all the time. I've got a lot of other videos. I'm on LinkedIn. Look me up. Love to connect. Love to network. I do a lot of presentations in the area. I run 2 user groups, so I'm all over the place. And if you're in the Boston area, check out on meetup.com the Greater Boston Data Science, Machine Learning, and AI group. Thank you.